So, make sure audio is working. Live TV. Hey everybody. Sweet. Hey everybody. So for today, we'll be going through a quick introduction into drivers, how they work, how you can use them in your application, and what we'll do is this will be an introduction to a video coming up maybe even next week on kind of rolling your own drivers or creating your own or modifying drivers and putting them external to the tree of either Zephyr tree or your project tree. So we'll dive into that a little bit, but this will be hopefully useful for you guys, and we'll kick this into high gear. Sorry about last week. I was moving and that was crazy, so all that moving craziness is done, so we should be back to our regular scheduled programming coming forward. So we'll have a live stream next week, so stay tuned for that. So, and if you haven't already, that'd be great. Let's get going. So what we're going to be using is the sensor API for drivers. It is a generic API that you can use across many different sensors. So you can use that same sensor API for different sensors on different buses. So for instance, I2C, SPI, so on and so forth. So it takes away or abstracts away all the sensor specific information, and really you only have to focus on fetching data, getting the data, setting any attributes or setting any information for your sensor, so on and so forth. So it takes away a lot of the sensor specifics. So I'll show you some of the sensor specific stuff shortly, but that's just something to keep in mind with Zephyr, is that they've created the sensor API. So basically, if you have multiple accelerometers, maybe one's on SPI, maybe one's on I2C, maybe you're switching from one device to another, as long as there's a driver targeted for the sensor API, you can jump between different sensors fairly easily, as long as they both have the same kind of compatibility, the same callbacks implemented inside the driver. So what's important about drivers is that the overall structure not very much different from anywhere else in Zephyr. So there's a Kconfig, which basically has like a top level kind of configuration variable that's going to enable or disable the compilation of all the driver assets, and then within it you're going to there's a bunch of different configuration variables depending on the driver itself, which are going to define how the device operates. Maybe these are kind of sane defaults that you're going to use that are already defined. Sometimes there are things that you need to define. So I'll show you that in a minute. And then there is that specific sensor API that I mentioned that we're going to be using to fetch the data. And as I mentioned, it can be used across various different types of sensors. In this case, in this example, we'll be focusing mostly on accelerometer, but like I said, it can be used in many different ways. So let's jump over to the exact Kconfig, as I mentioned. So here you see the I'm going to switch, you can see me real quick. So you can see that the LAS2DH, that's the main menu config option. So that's the one that's actually going to kind of turn everything on. You define that, so config underscore LAS2DH, that's going to be put into your project prj.conf. And that's going to basically tell the compiler, hey, I want you to compile all the LAS2DH files. All those files are defined in that project's, in the driver's CMake list file. So there's nothing you really have to worry about. This particular driver is actually built into Zephyr, and many other drivers are built into Zephyr. That's what's nice about Zephyr. There's a lot of kind of batteries included stuff, so you don't even have to worry about bringing it in your project or creating your own driver. and it makes things a lot easier. I know, for instance, ST has their Zephyr compatible library that they kind of it's showing up in my Zephyr repo or one of the modules, and that's not 100% compatible with the sensor API, but that's also another resource where you can just call things. You can call functions directly that are provided by the manufacturers. So that's another resource that's there. Now let's jump over to PRJConf. So this is the kind of the bare minimum of what you might need. This is for the LIS2DH, which is a 3-axis accelerometer. I'm going to be using it on I2C, so I2C needs to be enabled. We're using the sensor API, so that needs to be turned on. So config_sensor equals Y. And then we're also enabling the driver itself, kind of like what I mentioned before. So that's config_lis2dh equals Y. Now, there's some other things here that's also interesting or important to know. See, if you want to use, excuse me, if you want to use external interrupts, you can either enable a global thread, which actually uses the system work queue. And if you guys haven't seen the kind of live stream that I did on all types of different ways you can do any processing in Zephyr, I think it was the last one, so feel free to jump back to that one and check it out. But that is using a system work queue thread and running on the system work queue, or you can actually configure it to have its own thread. So very handy. Those work. The way that works is that you're essentially creating an interrupt event, and what you want to do is actually set the processing or any fetching that you're going to be doing within a standard kind of system thread. You can't really do any, like these are hooked up to GPIO interrupts. So when those GPIO interrupts happen, you're in an interrupt context, so you're not going to be able to run any I2C commands to actually read the sensor. So it receives the interrupt, and then it basically queues up the work either in a system work queue thread or in your own thread. So that's what that is all about. And then, as I mentioned before, those other two options down there, those guys are for configuring for default values. So I believe the 2G and the ODR-_2 are the defaults. But as you can see, you can kind of change these guys statically, so that's the way they're set at the beginning. And that's all depending on the driver. So the driver actually has to look at those variables and make sure that they're set correctly. Let's move on to the next part. Another important part is the overlay file. So here is an example of actually importing the LIS2DH into the I2C1 interface. Now, the important part, this is probably one of the more important parts. This is actually what's connecting the driver to your hardware. So you need to define the device. And you can also see that I'm using I2C address, and that's actually defined in two places. So you see LIS2DH and then that @ symbol in 18. So that's one place where we're using the address of 18, essentially hex 18. And then if you go down to the reg equals, and then we also have that hex address there. That's the address of the device, and that's important to set correctly, or else you won't be able to communicate with the device. Then you have the IRQ GPIOs. These guys are, I'm using them for, the device actually has two interrupt pins. So one is used for interrupt 1, one is used for interrupt 2. These are actually the pins on the NRF9160 feather, which are connected to each of those. Depending on your device, you might have more than one GPIO interface. So for instance, the NRF9160 only has one GPIO interface. For example, the NRF52, the NRF53, they have two GPIO banks. So those are references GPIO 0 and GPIO 1. And obviously, as you get bigger in the types of processors, you're going to have multiple interfaces, especially for ones that have like a BGA array, 500 pins, things like that. So, and I know those exist, most likely exist on Zephyr. So, something to keep in mind. And importantly, you can also see this disconnect SDO SAO pull up. So this is an example of an option in the device tree definition, which when you define it, that is actually in the driver, it's actually looked at and is determined whether or not that is active. And then in that case, the driver will do a certain piece of logic depending on whether or not it's on or off, or in this case, if it is active or if it's present, it will actually disable the internal pull-up on this device's on the address select pin. So it's just another thing. This is kind of like where the line blurs between an overlay file and and your project configuration, and it's just like what's more hardware and what's more like configuration. So in this case, the folks who wrote the driver decided, okay, this part of the configuration is part of what would be in the overlay rather than having it in the Kconfig. So you might find that other drivers might put this in as a Kconfig variable versus putting it in the overlay. So you just gotta look out for it, and you can actually dive into the drivers and see how it's been implemented. Not all drivers are documented well, so you actually might have to dive into the code and actually see how it works in order to figure out how to use it the best. So next. So here's a quick way of getting that driver in there. So if you look back here, the DT instant or INST, we're getting the first instance of ST-LAS2DH, and that instance, if you look at what it's really looking at is that compatible line. So if you look at this compatible line right here, it has the ST, LAS2DH. So essentially, what it's going to be looking for is that LAS. It takes that comma and gets rid of it and replaces it with an underscore, essentially. So it's looking for ST underscore LAS2DH. So we're looking for that first instance, and then we're using the latest SDK way of getting the device. So that device underscore DT underscore get is rather new. And that will allow you to get that sensor, pull it in, and then what I'm doing here at the bottom half is actually checking to make sure it's valid, and it's also that it's initialized and it's ready. If there are any errors during the initialization process, that'll essentially return false, and then you'll know that something's wrong with your driver or your device or your driver or whatnot, and then you can't use it. And then further on in the sample, I'm just like showing you what it's essentially doing. The interrupts are turned off, and then it's running this fetch and display function, which is essentially running these guys. So it's running the sensor underscore sample fetch function, and this is just telling the sensor to fetch the samples, and then those samples just get saved in kind of static memory. And then what you can do is you can run the sensor channel get. And what we're doing is we're targeting, the way the sensor API works is that you can have multiple sensor channels for a device. And what we're doing is we're targeting a specific quote unquote channel that you can get data from. So in this case, we're using the accelerometer XYZ channel. This channel, there are many definitions of these channels. So if you look at, I think I put those in here. This is just an example. There's a huge list in the sensor.h file. There's like lots of different sensors, the PM 2.5, humidity, temperature, you name it, all those things are in there. So what you're doing is you're essentially sending an enum to that sensor API, and on the other end, you're actually just checking to make sure that the channel that you're trying to fetch from is one that's compatible. And if it's not compatible, it will return an error But in this case, we're trying to access variables that we know will work, or the channel that we know will work, which is the XYZ accelerometer channel. And what's interesting about this is that not only can you fetch a single piece of data from this API, but you can fetch multiple pieces of sensor values. So you see the sensor value here. You can actually fetch multiple of those at the same time. So depending on how you write your driver, maybe you want to get just multiple sensor values at the same time of the same channel. You can set it up to do something like that. But in this case, I'm actually reading the X, Y, and Z values, and those get all put into separate sensor value structs. So just create an array and pass that array in, and then it's already set within the code to fetch those three values. So you have to make sure that you're providing enough static memory for it to use. So in this case, we're allocating those three sensor value structs for it to basically place the data into. And then essentially what's happening at the end here is that we're just printing out those pieces of data. And I'll show you guys, it's running in a second here, but you can see that we're using the index 0, 1, and 2, and we're converting those values, which are typically in two 16-bit numbers, which are just essentially representing a double, but it's converting those actual double type in the code. So if that makes sense. And that's about it, but I'm gonna just jump into the code real quick and just give you a little idea of what's going on. I'll just kind of recap what we just talked about. So let me jump this over here if I can. So jumping back to the Kconfig, you can see like there's all types of different types of configurations. You can see kind of what I mentioned before: global thread, your own thread, and then you can set like the trigger priority. You have like thread stack size, which generally, if someone's tuned this driver, it doesn't really have to be tweaked unless you're doing something. Unless you've modified the driver, and then you might have to increase stack size. A lot of these things you don't have to worry about. But if you're working with, for instance, Excel range, if you're working with a range that's higher, if you know you are, then you can set these things as a default instead of changing them during runtime. But it's really up to you and how you like to code your applications. You can set like the ODRs, like how often the data is sampled from the device, resolution, things like that. Let's see. And then you can see on the side here kind of what's included in the sensor driver folder. You can see all these files right here. Hopefully it's big enough for you guys to see. But that's located in Zephyr. So that's in like the root Zephyr directory, drivers, and then we're going to go down to sensor. And that's basically what's covered in the sensor API. And then you can just go down to LAS2DH. So if you're actually looking for a sensor or a device that you're already using or that you want to use, you can check out this folder and actually see if it's in there. Or if you're using something like VS Code, you can actually like search for it. So for instance, like there's a whole bunch of results for LAS2DH, so it's a good sign that you're actually using that. The driver's available in Zephyr, or like LAS3MDL, which is a magnetometer, and they have a sensor there as well. So, someone's at the door. I don't know how it's possible. So let's jump over to. So also, this is what the Kconfig CMake lists actually look like. This is what the CMake list looks like. You're just pulling in the different C files. So when when everything is enabled, when you're enabling that Kconfig, then these are the guys that actually get compiled. So you can see this is all like conditional. If you go back to, let me see, like for instance, this config ls trigger, the trigger stuff only gets compiled when trigger is actually on. And then if you go to like the CMake list further up, then you can see like config, let me see if I can find ls. There's a whole bunch of different options here. So like as long as this guy's on, then it'll actually it'll compile the folder. So just something to keep in mind. That's just kind of how it's structured, and the more you play around in here, the more you'll kind of get used to it, especially if you're trying to pull in your own drivers and things like that. And then otherwise, let's see if there's anything else of note in here. You got, it's what I recommend, especially if you're going to be playing with the driver, that you just check out the drivers itself and how they're structured. The biggest thing, this one's a little bit more complicated, only because it has an option for both using SPY and I2C. So that's something that you'll just need to you got to work through. There's a lot of crazy macros here. Not all drivers are like that. Only ones that have to share the two interfaces where it kind of gets crazy. So, but I will jump over back to the example code here. So one thing you can see, this is I believe this is the standard. I've slightly modified it for the NRF9160 Feather, but this is the standard example from Zephyr. So just pulling the values, just changing the which accelerometer to use. So, but you can see like conditional compilation. If we're using the trigger, then we're using the trigger mode rather than the just polling. But in this case, they're just using polling. So if you run down here, quiet you. So I'll just run flashing. So I'm using Zephyr tools here and just flashing the application. And I just have it hooked up here on my desk and just pulling the data from the accelerometer. And if I tilt it, it should change in value. You can see the X value going up. But what is, we're initializing, we're getting that driver, we're basically looking at the device tree and making sure that that device is there. And then what happens on startup is that it will call that, if you go back to the driver, actually, we'll go to the I2C one because that's the one we're actually using. But it's this init function gets called, and then depending on the driver type, either I2C or SPY, that then calls the specific initialization function for that data type or that bus type. So, yeah, what's happening here, that's already been called in the back end when the device is actually turning on. So all we're doing is just getting a reference to that device so we can actually do things with it. So we're just checking if it's ready. We're getting make sure that's not null, and then depending on the situation. So we're just, again, we're using this fetch and display function. So we're fetching, and then as long as that's successful, then we'll just get that, we'll get this data using the channel get, and that's putting all that data into this array struct of the sensor value, generic sensor value, the same sensor value that's in sensor.h. And you can see, oh yeah, okay, they're in 32s, not in 16s. So you can see the integer part, and then the part that's to the left of the decimal point, and then the part to the right of the decimal point is value 2. So something to keep in mind. Some drivers will use it, some drivers don't. It's purposely generic, so many drivers might have different pieces of data that you can pull at the same time. It is the advantage of Zephyr and also the downfall if you don't know what the driver is providing in terms of data. But once you get it, as long as that data is valid, then you're just printing it out here. So you guys can do something like this too. There's lots of drivers, but the general gist of it is the same. You're going to be configuring it with your project configuration. So that's the same thing I showed you before. But you can see like all the other things in my project configuration, turning on the MCU boot, and also I guess it required some libc stuff. Oh, for using printing floats, you can actually print these variables as well by just using the value1, putting a literal dot, and then putting value2. So for instance, if I just change this guy to this val1 and then val2, then you can just do so for instance, that's the cheap way of doing it. Then you don't have to pull in the crazy printf library or anything like that. So something to keep in mind. And it's just like something you just discover as you go on. The only thing is, another caveat to this is that if you are pulling this, you don't need the references, but if you are pulling this in, if you're working with a negative number, your value2 is also going to be negative, so you might have to use the absolute value function just to make it non-negative. Let's see. But that is about it for drivers. Feel free to share any questions that you have. Goliath, message retracted. Hey, Sona mate. Hello for Princeton. And hey, Jonathan. So that's pretty much just the drivers. This is kind of a basic example. The LAS2DH is a fairly basic, simple to work with. But beyond the fact that it is complicated when you're I2C versus SPI. So that's just like an extra bit there. But I encourage you to check out the rest of the samples in Zephyr, or the samples. The sample code is great because Zephyr has a lot of example sensor code that you can probably just use with your device without much modification, just so you can check it out. For instance, that accelerometer example is something that you can use, and it's already built in. And for instance, the only thing I really had to do for the NRF9160 Feather is just enable bootloader mode, and everything else just works. And then obviously you just have to create an overlay to actually and modify the project.conf depending on what driver you're using, what device you're using. So just complicated, but not. So I hope this has helped you, and I'm just going to check if anybody else has any questions. I don't think so. So feel free to leave a comment if you do, and I'll get back to you. And if you have any suggestions about what we could talk about next time, feel free to leave a comment, send me a message, or contact me. All my information is in the description box below. So looking forward to the next one, and I will likely be doing, as I mentioned, some more in-depth stuff for writing drivers in Zephyr and then getting them working with your project. That one will be probably a little bit more in-depth. But for those who celebrate Christmas, have a Merry Christmas.